Hi, this is Jeff Brunner. I'm a member of the ABB HVACR application engineering team, and in this video, I'd like to introduce the enhanced diagnostic capabilities of the ACH580. Now, there are two separate log histories maintained in the drive, each capable of storing up to 32 entries, and these operate on a first in, first out basis. So once at capacity, the oldest items are deleted first, and the new ones are added. Now, the difference between these logs is that one records faults and the other records events. And you might be asking yourself, well, what's the difference? Well, faults are conditions that cause the drive to stop modulating, such as overcurrent, DC bus over or under voltage, over temperature, short circuits, things like that. And events are transitions in operating state, such as start-stop, safety interlock opening up, handoff auto transitions, etc. But an important item they have in common is the entries in either log contain a timestamp, and this provides great insight into what a sequence of events would be, not only within a particular log, but also between the logs, as the timing of faults and events in the different logs can be cross-referenced to build a timeline of activity leading up to some incident that occurred with the drive. And so these entries are really helpful in identifying patterns while troubleshooting issues. So this video is going to focus specifically on the event log, and there's a separate video that dives into great detail on the fault history. So let's get on with the demo, and I thought the best way to do this would to actually go through some sequences operating the drive and check out the event log as it builds as these different events take place. Okay, so I've got the ACH580 panel up here, and we'll begin by just navigating over to where these event logs exist and take a look and see where we're at. So we'll navigate here to diagnostics, fault and event log. And now we see that we got our two logs here, faults and other events. And I cheated and I've completely cleared these, and I'll get into how to do that at the end. So currently we have no faults, and we have got just our power up event, which I did after I cleared the faults. So now we'll back out. Now, we'll just stay right here at other events. Okay, so the first we're going to do here is I'm just going to push the off button. So now we've transitioned to the off state. Now let's go in the event log and see what that looks like. Okay, we see the off mode has been selected, and it gives us the timestamp. So we'll back out, and now let's go to hand. Okay, so we have a set point here, and so now we're actually running. So we've transitioned from off to hand, and now let's see what events are added in the log. All right, so we see that modulating started as we push the hand button. The state transition shows up just slightly after the modulation actually started. So let's go back out, and now we'll transition to auto. And of course, I don't have a run command active at this moment, so it's a simple transition from hand to auto. Modulating stops, and we see now that we're in auto mode. And we'll back out. And now let's throw a start command. So I'm going to close DI1 on my demo case. Okay. And now we can see that we've started in auto mode. So let's see what that looks like. Okay. Auto mode selected. Now we'll see the auto start and the modulation started. Great. So now we're running. And so now we'll stop the drive. Okay. And we'll take a look at the event log. Okay, so now I can see stop command and modulation stops. Great. So now we'll start again. And this time I am going to let's open up a safety while we're running. So, okay, we get the interlock warning. Okay, how does that look at the event log? Okay, modulation started, then the start interlock opened, and we can see, again, that the timestamp is great here because we can see the whole sequence of operation. Okay, so now I will make a safety again, and we'll start again. Again, you can see that sequence of events in here. Back out. What else have I got here? Oh, I got supervision programmed in the drive. So let me raise the set point. The supervision is set for 40 Hertz. So this should trigger the supervision, which it does. So let's take a look at the event log. Okay, signal supervision. Oh, that reminds me. The other thing I want to point out here is you see some of this is in bold and some of it is in gray. And so the bold icon indicates that that's active. And when it's grayed out like this, that means it's inactive. So now we can see that we've got signal supervision is active. So we'll back out. Now I will reduce the set point back below the trigger. And now we should see that the supervision is clear, which we do. Great. Okay, so I've also got the drive set up to fault to be triggered by one of the digital inputs. So let's generate a fault. Okay, so we see that we've got a fault now. So let's hide that temporarily. And now let's check out the fault log. Okay, so now we've got an entry in the fault log with its corresponding timestamp. Then, as I said to you earlier, we can then use both logs together to see, okay, same timestamp, modulation stopped due to the fault. So now I will back out to clear that fault. And my run command is still active. So we start up again right away. And now we'll see here again, you see the transition for a fault reset. And we'll see that our modulation has started again. And then finally, I will open up DI1, and that will bring the drive to a stop state. Okay, so then a couple of other things I want to point out here with respect to the event logger. And we're going to go into parameters, and we'll go into group 96. And there's some setup that can be done with respect to the event logger as well. So we'll scroll down here to the event configuration. So in here, there's 8 events that you can enable or disable. So these are the ones that more commonly occur and could fill up the buffer unnecessarily. So you can go into this list and select which one of these you would like to enable or disable. So that's a very powerful tool to help clear up the event log and keep it to be not so cluttered. And then finally, I alluded to this as well earlier in the video, but here we can go and actually clear it. Okay, so now it's completely reset. So here's a great way to leave a system perhaps after you've just finished commissioning, or if you're doing some diagnostics and you want to start fresh, a new stage in your troubleshooting. Here we can go now and see that we're starting from a completely cleared state again, just like we started. One additional item here that I neglected to cover, and that is what is actually in the event log on a particular entry. So let's go back into the event log and select one of the events and navigate just a bit deeper and see, well, what is the content here? Okay, so here's the details. We get, of course, the textual description of it. As well, we get the corresponding hex code. And then we have what's called the aux code. So some faults and events, there's multiple underlying triggers for the common fault or event, and that would be captured here in the aux code. In this case, there is no aux code associated. As well, we see then the specific date and time when the event occurred, and then we get a notation on what the drive on time has been. So that's the details that are contained in the event log. So that's the event logger in a nutshell. In wrapping up this video, I'd like to mention an actual scenario that played out recently where use of the event logger would have been very instrumental in solving the issue. I got a call from one of our reps who was supporting a tech on site at a job, starting up some fans for the first time. And the issue being reported was that the drive output contactor kept opening every time the drive attempted to start. And this issue was being reported on more than one drive. So I gathered the usual additional information and determined these were BCR bypass units using BACnet. So my first question was whether any faults or warnings were being reported on either the bypass or drive displays. And it was reported from the tech on site that there were none. Then I asked if any comms were being used for the application, and the answer was yes, BACnet. So I suggested disconnecting the comms connection just to rule out something BACnet related, and yet the problem persisted. In the meantime, all the wiring to the unit and the motor was rechecked, and everything was confirmed to be okay. So I asked again about any warnings or fault being displayed, and it was reported again that there were none. Finally, after some additional back and forth, it was determined that the BAS system was incorrectly sequencing the start interlock input and was opening at the wrong time. Now, this is a classic example of how the event log could have been used to verify whether any faults or events had occurred that were somehow unobserved, yet actually occurring, and directly identifying the cause of the issue. So that's just an example of how the event logger could really have helped out in this case. And with that, I'll close and remind you to reach out to your local ABB representative if you have any questions. Thanks for watching.